Yes, class, Sufyan and Taha. So we have done the potential energies formula. Formula is K Q1 Q2 divided by R. Now, first part at least you both should answer. Second and third and fourth I'll tell. Take 2 to 3 minutes, answer the first part, then I'll discuss. Answer in the chat column.
Ma'am, can you repeat that?
Yes, Taha, I said to answer the first part. I was saying that we have discussed the formula in the last class. First part, I just want you to answer. Sufyan has already answered. Taha, you also try, then I'll discuss it. Okay, both of you have answered. Let us see now. See, Q1 is equal to 2 millicoulombs, means 2 into 10 to the power minus 3 coulombs. Q2 is equal to minus 3 microcoulomb, which is minus 3 into 10 to the power minus 3 coulomb. And separation is 3 millimeters. The formula of potential energy is U is equal to K, Q1, Q2 divided by R. K is 9 into 10 to the power 9. Q1 is 2 into 10 to the power minus 3. Q2 is minus 3 into 10 to the power minus 3 divided by 3 into, see, 3 millimeters. It is 3 into 10 to the power minus 3 meters. So 3 into 10 to the power minus 3 meters. So 10 to the power minus 3, 10 to the power minus 3 cancel. 3, 3 cancel. So this is equal to, this is 18 minus 18 into 10 to the power 6 joules. What were your answers? 2 into 10 to the power minus 13. No, Taha. Minus 53.
Isn't it minus 6 coulomb?
Yes. Oh, sorry. Okay.
Isn't it
Sufyan's is
Q2?
minus 53.94. No, both
No,
are
no,
wrong.
ma'am.
Sufyan's is also
For
incorrect and
Q2.
Taha's is incorrect. Now, have you seen the correction?
Yes, ma'am.
Okay. Taha, you also?
Yes, ma'am.
Okay. Now, second part says work done to make the system. Work done to make the system is same thing. See, this is the first part, right? Second part means work done to make the system means the change in potential energy. So it is equal to minus 18 into 10 to the power 6 joules. If it is work done to break the system, then it is negative. Now decide whether the system is bounded or unbounded. See, a small theory portion here you have. Whenever we are calculating the potential energy, systems can be bounded or unbounded. Bounded means if it is negative of potential energy, and unbounded means if it is positive. All right. Now yours is minus 18. Our answer is, our potential energy is minus 18 into 10 to the power 6. So this minus sign signifies negative sign, which indicates bounded. Then it says if it is bounded, so yes, it is bounded. What is the work done to break the system? Always remember, work done to make the system is negative of work done to break the system. So work done to break the system is minus of 18 into 10 to the power 6, which is equal to 18 into 10 to the power 6 joules. Q2, what you're saying, Taha, Q2 wasn't 3 into 10 to the power minus 6. Okay, yes, right. This was minus 6. Milli, correct. This is micro. I've written this as milli. So this, if this is minus 6, then these two will be cancelled. I'm writing this is minus 6. So 3 to the power 3 will be left. Here we'll have the power 3. So yes, Taha. Thank you, Taha. Correct answer, Taha. I had written it as minus 10 to the power minus 3, but it would be minus 6 because it is micro. Write it. We'll discuss one more question from this. Okay, see, now class, one thing. In this question, it appears as if we are calculating four potential energies. Yes, we are calculating four potential energies of the system. So basically, we have four charges. So it doesn't mean that we have to calculate four or we will be getting four potential energies. Why? One is this. Second is this. Third is this. Fourth is this one. This is the fifth and this is the sixth. So these diagonals also you have to consider. These diagonals also you have to consider whenever you're talking about the potential energies. Why? We have studied, just a second class. We have studied that potential energy comes in the system due to interaction. Now, interaction means we have already discussed that this is due to the forces. So if Q and 2Q are exerting force on each other, 2Q and minus QR, minus 2Q and minus QR, Q and minus 2QR. So this A point and C point, that is plus Q and minus Q, will also be exerting force, and plus 2Q and minus 2Q. That's why these diagonals also you have to count. Now formula is K. What's the general formula? General formula is K Q1 Q2 by R. So you'll be putting into this K. Now charge between A and B point. A point is Q, B point is 2Q, separation is A, plus B and C, second one, K, 2Q, this is minus Q. So K into 2Q into minus Q divided by A. Then C point and D point, these two. So this is K minus Q into minus 2Q divided by A. Then between these two, this is K minus 2Q into Q divided by A. So these four are over. Now these two are left, fifth and sixth. Now for fifth and sixth, we require one more thing. We require the diagonal. So it's like this, A, A. So this will be root 2A, A root 2, right? We'll be using the Pythagoras theorem. So under root A square plus A square, that will give us 2A square, which is equal to root 2A. So this fifth is, this is K, Q into minus Q divided by root 2A. Sixth is K into 2Q minus 2Q divided by root 2A. This is the formula of it. So what we can do, we can take K, Q square by A common. Let's see what are we left with. K Q square by A. So 2. K Q square by A. So minus 2. K Q square by A. So again plus 2. K Q square by A. So again minus 2. K Q square by A. So minus 1 by root 2. From here K into Q square by A. So minus 4 by root 2. These two get cancelled, these two get cancelled. So what's the final answer? K Q square by A minus 5 root 2 joules. Write it. This is the formula. Okay, this is the potential energy of electric dipole. Now, class dipole moment we have already studied. What was dipole moment? The two charges which are present, plus q and minus q. So charges of opposite signs are present and they have a certain separation between them. So if two charges are present of certain separation, then we say it's a dipole. Yes. So torque, how do we calculate the torque? Torque is basically the cross product of dipole moment and electric field. So tau is equal to PE sine theta. Now external torque acting on the dipole torque external is minus tau. Now what is work done? We say work done is force into displacement. Force in rotation is written as tau and displacement is written as d theta. So work done is tau dot d theta. So you have, if the dipole is rotating from one angle to another, from theta 1 to theta 2, so we'll integrate it from theta 1 to theta 2. So torque is written as PE, P cross E, right? So torque was P cross E, so that's why we'll use PE sine theta d theta. Now, when you integrate it, PE, both are constant, so P and E come out of the bracket and we are left with minus cos theta from theta 1 to theta 2. So here, when you put the value PE minus, let's put it here. So this becomes cos theta 2 minus cos theta 1. Cos theta 2 minus cos theta 1. So this is work done. This gets stored, this work done gets stored in the form of potential energy. So our potential energy has the same formula, minus PE cos theta 2 minus cos theta 1. So this formula you have to remember. Suppose if you do not have to put the negative sign, you can use PE, but you have to interchange these, cos theta 1 minus cos theta 2. So for example, if one angle suppose is 90 degree, let's say this is 90 degree. So if the one angle, let's say theta 2 is 90 degree, so formula will be PE cos theta. Okay, but the main formula is this. We'll be using this. Focus on this. Write down the derivation first, then I'll discuss rest of the things from this. Okay, now work done by the electric field. When you're calculating the electric field, so it is negative of work done by the external field. So potential energy is minus P cos theta. So three types of angles we will discuss, three cases. One is when both are parallel, electric field and dipole both are parallel. So theta is 0 degree. Means dipole is completely aligned to electric field. P is in parallel alignment with electric. So theta is 0. Then we have when the dipole is aligned at 180 degree and last case at 90 degree. So see, when once you have it aligned to the 0 degree, so we'll have P E cos 0 degree minus P cos 0 degree. So we can write it as minus P E. Negative potential energy means the maximum and stable equilibrium condition. It's the stable energy and this is the maximum potential energy possible. If it is minus PE cos 180 degrees, so this is equal to minus PE into minus 1. So this is equal to plus PE. So this shows an unstable and minimum potential energy. Last one is minus PE cos 90 degree. So this is equal to 0. Write down this two. Not just copy the question answer. See, it's direct. Dipole is given, electric field is given. Now you just have to fit in the angles. Okay, see, now I'm solving it. I think enough time was given. Dipole moment is equal to 2 coulomb meter. This is placed in an external electric field. Electric field is 10 Newton per coulomb. You have to calculate the work done by external torque in rotating dipole from parallel to anti-parallel position. Now, what is meant by this? See, parallel means first angle is 0 degree. To anti-parallel means second angle is 180 degrees. So if you put it here, work done is equal to minus PE cos theta 2 minus cos theta 1. So this is minus 2 into 10. This is cos 180 degree minus cos 0 degree. So this is equal to minus 20. This is minus 1. This is minus 1. So minus 1 into minus 1 means minus 2. Minus 2 into minus 20 is, this is minus 2 into minus 20, it is 40 joules, right? Minus 1, minus 1. So minus 2, so 40 joules. This is the answer for the first part. Second part says, work done by electric field. See, this is the work done by external torque. Work done by electric field is negative. This I have already told you earlier also. So electric field is negative of the work done by the external field. So it is minus 40 joules. Third part says calculate potential energy difference between part 1 and part 2. Calculate potential energy difference in part 1. Okay, potential energy difference. See, potential energy is the same. Third part says potential energy. See, potential energy difference is exactly the same as that of work done. So it is 40 joules. Last part says calculate potential energy if dipole is placed at 60 degree with respect to field. Now see, other angle is not mentioned. If it is not mentioned, you are going to use the formula minus PE cos theta. So this is minus 2 into 10 into cos 60 degree. So this is minus 2 into 10 into half. 2 gets cancelled. This is equal to minus 10. Write it. This completes with potential energy. Now we are just left with capacitance and its combination. Write it first. See, what is meant by capacitance? So the ability to store charges is called capacitance. And the device that does this is called a capacitor. So capacitance is the ability to store charge. So this is, or charge you can say, or electric potential energy you can say. So it's the ability to store charge or electric potential energy. And the device that stores the charge is called a capacitor. So the ratio of charge and potential is called capacitance. So capacitance has a formula, charge divided by the potential. And it's a very important formula. Q is the charge and V is the potential. So SI unit is farad, 1 farad, like this you will see examples, 5 microfarad or 3 millifarad or 4 picofarad, like this. This is the example. Write it down.